Yes, good afternoon all. Can you hear me? Yeah.
Good afternoon.
Yeah, good afternoon. Yes.
Good afternoon.
Just wait for one sec, हाँ? मैं थोड़ा claim host, हाँ, I'm host. Yes, Abhishek? Want to say anything?
Yes, ma'am.
Okay. बोलो. Do you want to say anything? I said. अच्छा, who is here?
064 Animesh.
Animesh. Okay, Animesh. What was the last thing? Can you tell me? Any of you, not only Animesh, any of you. What was the last thing that we did in the class? Two numericals we did, है ना? Yeah, very correct. चलो, तो we'll go ahead now. हमने थोड़े से बेसिक न्यूमेरिकल्स देखने की कोशिश की रेजिस्टेंस के. I'm expecting you are having BL Theraja with you, or you got the BL Theraja book मिला आपको?
No, ma'am.
नहीं.
No, ma'am, नहीं मिली.
अच्छा ठीक है, मैं एक ना सॉफ्ट कॉपी है मेरे पास. सॉफ्ट कॉपी यू आर हैविंग?
No, ma'am.
और वो भी नहीं है. ठीक है, मैं ना आज मूडल पे डालती हूँ. So please try to open that and try to solve the numericals from first chapter, okay? Based on whatever we took in the last lecture and today's lecture, whatever we take. So very simple thing. In the first lecture, we'll try to solve some basic formula we had seen. R is equal to rho L by A. And based on that, we try to solve one or two numericals, right? So every time we'll do this thing. 1 minute देना मुझे, मैं चार्जिंग को लगाती हूँ. लैपटॉप मेरा. Okay. So what we'll do is again small topic, थोड़ा सा theory करेंगे, and based on that we'll start numeric. Okay. So we'll keep on doing this, so it will be easy for us and bore नहीं होगा. सिर्फ theory कर रहे हैं, सिर्फ numerical कर रहे हैं. सिर्फ numerical तो it's never boring as per my logic. But only theory, right? It becomes boring. So let us go for it. Okay. So I'm talking about now the next. उसका कनेक्शन में the next thing. रेजिस्टेंस का ही पार्ट कर रहे हैं एंड उसमें नेक्स्ट पॉइंट कंडक्टेंस. एंड कंडक्टिविटी. Conductance and conductivity. What do you understand by conductance or conductivity? Forget about conductivity. Just talk about conductance. What do you understand by that? Yes. Division 2.
It is the inverse of resistance.
Very good. Very absolutely correct. It is inverse of a resistance, one thing. And if you ask the definition, resistance was opposing the electricity flow. And this is the property which is going to allow current flow through it. Right? So whatever he said, conductance is reciprocal of resistance, one thing. Property to allow current pass through it. Property of substance to allow current flow through it. See why I'm writing? Because I want you to write. If I'll just show you the thing on PPT, I know you are not going to write here. You will just keep on taking the screenshots. Now also some of you are taking only screenshot. I know.
I'm writing.
भारत में हूँ क्लास में. अच्छा. So what I said, I want you to write. तो हर एक के पास नोटबुक है, पेंसिल है, पेन है. हाँ, जैसे मैं लिख रही हूँ on the same line, you are also writing, right? I want. कभी भी मैं किसी को भी बोलूंगी वीडियो शेयर करो. हाँ, ठीक है. So what is the unit of resistance? Yes. Sorry, conductance.
Move.
Move. Okay, very correct. So you used to write R is equal to, ये formula आपको पता है, rho L by A,
Yes.
है ना? Then you can write, therefore it is represented by G. Okay, and G is 1 by R actually by definition what we said.
ஜியோ அவ்வளவு கொண்டு வந்தியாடா?
இந்த நேரத்துல அதுவும் எதுவுமே சாப்பிடாமலே கூட இருந்திருப்பேன். எதுவுமே திங்காம நான் ஸ்கீல் சாப்பிட கூட போக மாட்டேன். இந்த இருக்குல்ல
Roll number 079. Mute कर.
நான் ஃபர்ஸ்ட்
Javi.
நான் யோசிச்சு எதுக்குமா யோசிச்சேன் காலேஜ்ல.
मैम उसको हिंदी नहीं आती.
उसको हिंदी नहीं आती बट अच्छा कर दिया उसने. एक तो लेट ज्वाइन करेगा फिर माइक ऑन रखेगा. दिस इज द थिंग. A upon rho by L है ना. 1 upon R means A upon rho L. Now instead of writing 1 upon rho, we can very well write it as conductance. 1 upon rho will be 1 upon resistance. So instead of writing 1 upon resistance, very well we can go for something for that, right? And that is represented by sigma. So sigma A by L, where the sigma is, we used to call it as specific conductance or conductivity. So I'll write sigma is specific conductance or conductivity. Right. Now, just someone said unit of this, so let me write it. Unit is mho, or it is also called as Siemens. Sorry, Siemens will be the unit of G. So I'll not write it over here. Actually, no. Mho and Siemens are same, but I'm writing it in a wrong place, right? I should write it for G. So what I'll do is I'll shift this thing slightly down. This will be better. Now I should write. So G and unit is mho, or it is also called as Siemens. Okay, and it can be represented by S, or sometimes you will find yes, it is represented as ulta ohm. That is mho. That's it, right? So some point of differences are there. Not different, it is difference. We learned all these things just for you to remember all the points properly. Right? I'll write them simultaneously next to each other. हाँ बोलो.
What's that symbol? S upon?
S upon नहीं है. S ये Siemens का है.
Okay.
और it is also represented as mho. और mho का symbol होता है उल्टा ओम.
Okay, ma'am. Okay. Thank you.
Yeah.
Got it. Thank you.
Yeah. Yeah. So I'm writing the differences just a minute. So resistance and conductance. We know everything now. We had seen. Okay, just enlisting the egg place where you will have everything, so it will become easy for you to remember the thing, nothing else. Chalo. So point number 1. Formula R is equal to rho L by A. Here it is represented by G, which is 1 upon R, which is A rho by L, or you can write sigma A by L. Okay. Then the second thing is, here you used to have specific resistance. Resistance. Or you say resistivity. You represent it by rho. Here you are going to have specific conductance. Or conductivity. And you represent it by sigma. Then the third thing, unit over here, you are going to have unit ohm. Here the unit is S. That is Siemens or mho. Then the fourth point. Whatever is the formula for rho, it is R A by L. R into A by L, right? Then for sigma, it is going to be G L by A. Correct. The last point, unit of rho, we had seen ohm meter. Correct. For sigma, see now you can see GA, so Siemens. And this is length, this will be length square, with a meter square, 1 meter got cancelled out. So per meter. So these are some point of difference. Keep in your mind, कभी question पूछ सकते exam में, है ना? IMU के exam में, so we should be aware of. चलो, किसी को कुछ doubt है अभी इसमें? Any of you, any doubt?
No.
Very correct. Good. Can I clear the board? Okay, good.
Ma'am, 2 minutes wait.
Yeah,
Wait
yeah.
for 2 minutes. I am
Yeah,
writing.
Prathamesh, I'll wait. You write it. आपका हो जाए तो मुझे बोल दे.
Excuse me, ma'am.
बोलो.
What is this 6?
क्या बोला फिर से बोल. ये this one.
Yes, ma'am.
This is sigma.
Okay, ma'am.
Is it okay? Yes.
Yes, ma'am. This is okay.
या हिमांशु, ठीक. ऐसे ही ड्रॉ करते हैं इसको. थोड़ा सा sometime, no, that is different. It should be this only. Huh?
Okay, ma'am.
Yeah. कर दो clear board. ये लिख रहे हो? Okay, okay, I will wait. Prathamesh, should I wait?
Yes, ma'am. I am done.
You have done. So can I clear the board? Yes. Others?
Yes, ma'am.
Yeah.
Yes, ma'am.
Yes.
Ma'am, wait, ma'am. I am ready.
Okay. I'll wait. Manthan, लिखो जल्दी जल्दी.
Yes, ma'am. Finished. Thank you.
Okay. Chalo, so I'll clear the board. Correct. Now the next thing. Now we want to go slightly more deeper into the resistance part, right? So we had seen basic formula. Now we are trying to go for what is the effect of temperature on this resistance, and might be a substances are different, right? So then what happens? So I'll write it first. What we are trying to see is effect of temperature on resistance. Okay, so and let us see if the material changes, then what happens to the resistance. That's it. So we are talking about increase in the temperature. If you are increasing the temperature, point number 1. Okay, I'm talking about metals. And remember this thing, huh? Why? Because your basics should be clear, because these things you will require in second year and fourth year, at least for control, where you are supposed to measure the temperature, and then who will measure the temperature, and how we used to measure the temperature in the plant or in the process. Assume करो कोई बड़ा सा reactor है, and और कुछ tank है, and some reaction is going on. Right, something is happening, some mixing and heating and all those things are happening. Now you want to record the temperature and you want to take some specific action depending upon the temperature. मान लो 50 से ज़्यादा temperature should not be there. So why? Because wherever this fluid is going, right, at that point is not allowed. Let us say I'm just giving you example. So then what you have to do, you have to control the amount of temperature over here. Now, if you want to control, first thing is you should be able to measure the temperature. आपको पहले पता तो हो कि temperature कितना है, then you will be able to control, है ना? So to know that, yes, you will require to measure the temperature. Now, we should think of all these things now, है ना? When we are talking about resistance part, which will convert the temperature into resistance, and then depending upon that, we'll be able to control the thing, right? So metals में क्या होता है? Increase in the temperature in metals, increase in the resistance. So metals में what happens is, if the temperature is increasing, you'll find resistance also increases. Okay, then it has positive temperature coefficient, have positive temperature coefficient. इसका मतलब क्या मैं बताती हूँ. And third very important point is extremely linear. Now what I mean by all these things, let me show you. Let me draw the thing. I am talking about input with respect to output. Acha, what do you mean by I'll tell you all these things. Just I want to know from your side. Do you know what do you mean by characteristics of an instrument? Yes. What do you understand by the word characteristics of my instrument? Means what? कोई एमीटर है आपके पास? Yes. Give to. Don't know. Okay. देखो जैसे.
No, ma'am.
Okay, fine. I will draw and I'll explain. This is very important, right? I've seen candidates in second year, third year, they don't know instrument characteristics means what. अरे ऐसे कैसे चलेगा है ना? This is a very basic thing. That means what I'm okay. Let me first clear the thing, right? What do you mean by input, output, and supply? So three things are there to every instrument. एक होता है इनपुट सिग्नल, एक होता है आउटपुट सिग्नल, and third is supply. What supply signal? It is not signal actually, it is the supply. Supply that we are giving to the system, right? So instead of talking emitter and this and that, this gadget is always 24 hour is with you, है ना? So I want you to give me answer for मोबाइल के लिए what is input, output and supply. तो can you tell me मोबाइल का input क्या होता है? हाँ भारत. चार्जर. जीतेश said charger. Then Bharat said current. है ना?
Yes, ma'am.
Yeah, current. Any other answer? सोचो सारे, मुझे चाहिए आप सबने सोचना. These two students tried to give the answer. Yes, Prathamesh, you want to say? हाँ.
Touch screen.
Very
Touch screen also
good.
give input.
Very good. Right. See, keep in your mind, whatever goes from user to the instrument is input. Whatever you said, your charger, your AC, getting converted into DC current or DC voltage, and then you are giving to the phone. This is supply. Energy required for the instrument to work, which is always constant, is the supply. Input is continuously changing. What Prathamesh said very nicely, he said, whatever touch screen on the screen, whatever signal that we are giving. So whatever touches you are giving to the screen. और एक क्लास में एक स्टूडेंट बोला था जो वॉल्यूम का बटन होता है, we used to press. Absolutely. You are changing the volume is the input, which is continuously changing. So whatever command that user is giving to the phone is the input. On the other side, depending upon the input, instrument gives back to the user something like volume change हो गया, screen, what we can say, some YouTube video is on, right? Or some Bluetooth connection you got now, or internet connection you got, some song is getting played. So this is from your instrument to the user. So that is output. Output is going to depend upon input. Input is continuously changing. Because of that, output will also continuously change. Correct? But supply will be always constant. एक बार आपने बैटरी चार्ज किया, when it will start dropping, कुछ होता है उसका span. राइट 5 का, उससे थोड़ा कम हुआ देन द मोबाइल विल बी ऑफ, फिर से आपको चार्ज करना पड़ेगा. Have you got everyone what I said? Yes.
Yes, ma'am.
Very, very correct. Right now, characteristic of an instrument or characteristic curve of an instrument means you are trying to plot output with respect to time output with respect to input ka graph. When you try to plot output with respect to input, whatever graph that you are getting, right, that is called as characteristic curve of your instrument. Every instrument will have input, everything in the world. Forget about the instrument and all these dry things, even human being, right? I'm having 3 students now, different students, right? Given same input to them. I told them this is the topic and you're supposed to study or whatever, right? Just I have given the info. Now, student number 1, very intelligent one. Whatever I taught or whatever material I have given, right? He just read the main points and trying to remember. This will be the output. Second student, very hard worker, will read everything, right? I have given 2-3 assignment based on that, will solve everything, right? So output is different. One student, very careless, right? Will not do anything for the given input, right? So definitely every human being is also an instrument, and continuously we are giving input to our brain or body, and depending upon that, yes, the output will keep on changing. Now it will depend upon what that human being is, what that instrument is, right? So this is input, this is output. Very well, all the 3 will have different 3 characteristics, right? So instrument के लिए graph में बात करते हैं. So we'll get different graphs from different instruments. So till now, right, whatever you studied till now, have you plotted anywhere any graph? Graph मतलब not all other graphs. I'm talking about characteristic curve. किसी का draw किया आपने अब तक? किया है, इसलिए मैं पूछ रही हूँ. आपने बिल्कुल किया है. That's why I'm asking you. आपने कौन से इंस्ट्रूमेंट का या मटेरियल का या anything in the whatever was your part of your study and you tried to draw the graph of
VI का बनाया.
हाँ,
PN junction.
VI ग्राफ बनाया मैंने.
वेरी करेक्ट. PN जंक्शन डायोड का ग्राफ आपने ड्रॉ किया. एब्सोल्युटली. It was coming out like this, right? What was there on the y-axis?
Voltage.
What was there on the y?
Current.
Current. And you had voltage on the x-axis. तो ये नहीं voltage था ना? Very correct. You were providing input. Because of that, you have found that yes, current is increasing, and at a particular point मतलब particular voltage, you had seen that yes, current increases. Absolutely, it's a characteristic curve. और कोई example? BH का y, sorry. हाँ देवीश, फिर से repeat करो थोड़ा louder.
VI ग्राफ जो था Ohm's law.
VI graph
For Ohm's law.
Ohm's law. Okay, fine, agree. Any other thing? Any other thing? You had hysteresis curve. Very correct. BH curve. Very correct, right? What you give? You give field strength. What you get? You get field intensity. नहीं, sorry, field density. ये intensity है और strength है और ये this you give है ना, N into I. And because of that, you get B, flux density, है ना? And you used to draw that hysteresis curve like this. Yes, it is for that particular material. Very correct. Very good. Chalo. So I'm trying to draw the same. है ना? ये बहुत बेसिक है चीजें, बट यू शुड बी अवेयर ऑफ ऑल दिस थिंग्स. दैट्स द थिंग. तो I have drawn, let us say whatever material you are having, metal, what you are giving is temperature, what you are getting is change in the resistance. What said over here? Have positive temperature coefficient. Why positive? Because you are increasing the temperature and resistance is also increasing. And metals used to have very linear characteristic. That's why a straight line I'm drawing. है ना? Now you will find that this is the important thing. इसीलिए टेम्परेचर मेजर करने के लिए इन द प्लांट यू विल फाइंड यस व्हाट इज यूज्ड आर RTDs, resistance temperature dependent, resistance temperature detector. Okay, those are called as RTDs. Okay, and those are made up of metals, and normally used metals are copper, Ni, nickel, and very important is PT, platinum. Okay, out of these three, mainly used you will find yes, it is PT. Why? Because the characteristics are very linear. है ना? So I'll tell you which one is used mostly. That is PT100. Any industry, आंखें बंद करके, you will find what they are using is PT100. Why? Again, because of its characteristics, very linear one, very sensitive, nicely it works. You will find what is used is PT. This is additional information I'm telling you. Now this PT100, just you enter your PVD, your ship, that is there are ship in the college. As soon as you'll enter, you'll find main engine is there. कभी गए हो आप? Have you visited PVD?
No, ma'am.
No. अच्छा.
No, ma'am.
Okay, fine, no problem. As soon as you कभी तो करोगे ना तो मेरे बातें याद रखो. As soon as you'll visit, you'll enter, you'll find main engine is there. Go on the first floor, and from here try to observe the main engine. You will find 7-8 RTDs are fixed on the top RTD, and all those are PT100. So what you have to remember for measurement of temperature, what is used mostly are metals. Why? Because they are having positive temperature coefficient. Positive का मतलब है increase in the temperature, increase in the resistance. Characteristics are extremely linear. Because of this, accuracy is very nice for RTDs, right? Those are called as RTDs. And what we are having many a times, 99% in the plant, it is going to be PT100. That's it. चलो, किसी को कुछ डाउट है तो बोलो. हाँ भारत, फिर से बोल.
No doubt.
No doubt. So someone said something.
I was saying just a second. I was writing.
Fine. You write it. Achha, you want this thing also? This is just a extra thing. Okay, if you are writing, write it. I'm not clearing the board actually. I thought this is just extra thing, so I cleared it.
नोट कर लेंगे ना ज्यादा सही रहेगा.
हाँ कर लो, कोई बात नहीं, आपकी मर्जी है, आप करते रहो कि आपके खुद के नोट्स होंगे. बिल्कुल, जो भी एक्स्ट्रा है वो भी नोट करते जाओ. वो आपका स्किल है. अभी आप कितना लिखते हो, कितना अटेंशन में यू आर डूइंग ऑल दिस थिंग्स, आपको हेल्प करेगा ये सारा चीज. हो जाए तो मुझे बोलना.
I'm done. Thank you, ma'am.
Yeah, it was RTD. Yeah, गलत मत रिकॉर्ड करना. It was RTD. Yeah. चलो, तो I'll clear the thing. Yes. हाँ, so एक मिनट है, फोन आ रहा है. हेलो, हाँ बोला. हाँ बोला ना. कुठे आहात तुम्ही? हा, तुम्ही आले का वरती? कुठला? Sorry, disturbance. चलो. Then what we were saying was, so metal के लिए हमने देख लिया, and we know yes, it's very important, but it's not only metals are important, so more things are there. So what are those? Let us go for it. Yeah. So the second one is when those are alloys. You will find alloys, the effect of temperature is not very what we can say, very small change in the temperature you are going to get, and it's very irregular. So for measurement of temperature and all, alloys are never used, but we should record all these things. So I'm writing for alloys, increase in the temperature, increase in the resistance. Again we are getting one thing, right? But we are seeing that, we know that increase in the temperature is very small. Small and irregular. ठीक है, हमने लिख के रखा what is the effect on all these things. Now the third type of material. Third type is your insulators or electrolytes. Now insulators like glass or mica or क्या होता है, rubber, right? All are insulators. Now what happens in insulators is the exactly reverse thing. Reverse thing means as the temperature increases, its resistance decreases. So let me write it. Have negative temperature coefficient. Negative temperature coefficient means you are trying to increase the temperature. At that time you will find yes, the resistance of the insulator decreases. Okay, now the fourth one, very important, and I think you learned this thing. Those are called as semiconductors. Do you know semiconductors? Yes? Yes or no? Yeah. Yeah. What is the effect of temperature on semiconductors? Do you know that? No? You don't know? So do you know what are thermistors?
No.
You don't know? You have not heard about? Okay. Thermistors, definitely it was there in your curriculum. है ना दर्शन?
Yes, ma'am. वो superconductor.
No, superconductor.
It was skipped, ma'am.
Yes, Prathamesh, what you said?
Nothing, ma'am.
Okay. Thermistors.
Oh, made from oxide of semiconductor. वो.
Yes, Darshan, what you are saying, I am not able to understand. आराम से बोल.
And they are thermistors made from oxide of semiconductor.
They are made up of semiconductors. Very correct. Thermistors are made up of semiconductors. Very correct. Right? So they are going to have PTC also, or they are going to have NTC also. अभी इसका मतलब क्या है, मैं ड्रॉ करती हूँ, मैं सब एक्सप्लेन करती हूँ. Don't get confused. Just a minute. Okay. So again, we are trying to plot how if temperature is changing, how resistance is varying. Okay. Sometimes first thing is, first very important point is, these are non-linear ones. तो आपको straight line नहीं मिलता. One thing. And second thing is, you will find some of the semiconductors, when temperature is increasing, resistance will also increase. Right, so it is PTC, positive temperature coefficient. Some of the semiconductors you'll find as the resistance is increasing, as the temperature is increasing, resistance will keep on dropping, and that is NTC. Okay, positive temperature coefficient, negative temperature coefficient, right? And for thermistors, right, whatever are used mostly are NTCs. Now, for what thermistors are used? Again, for measurement of temperature only, right? So, but compared with RTDs, you will find they are not that good. Why? Because first thing, they are having negative characteristics. NTC hai. Second thing is range, and all those things are also problem for thermistor. That's why semiconductors, you'll find PTCs and NTCs are both are there. Yes, thermistors are there, right, which are made up of semiconductors, but mostly used for temperature measurement are NTCs. Two things I told you, it is non-linear, first thing, and range is very restricted. Less range, I'll write. Yes, is it okay, everyone? Yeah. समझ में आया?
Yes, ma'am.
Ma'am.
एकदम थोड़ा टाइम के लिए माइक ऑन करके यस और नो बोलोगे ना, मुझे समझ में नहीं आता व्हाट यू आर सेइंग बिकॉज ऑफ लैग एंड दिस नॉइज एंड ऑल दोस थिंग्स. तो आराम से अनम्यूट करो, जो बोलना है बोलो, राइट? लेट मी गिव कमेंट ऑन दैट एंड देन यू म्यूट योरसेल्फ अगेन. ओके, सो आई डोंट थिंक किसी को अभी डाउट है. अगर डाउट है तो आप बोलते रहो बीच में, तो आई विल कम टू यू. Okay, even if you'll talk in between, no problem, right? Just point pe doubt hai, tell me, ma'am, stop here, I'm having doubt for this point, right? I'll try to clear your doubt. So the next thing comes now, temperature. Temperature coefficient of resistance. Okay, and now we are talking about metals only. Why? Because metals are very nicely working. Even if there is change in the temperature, whatever characteristics we want, we are getting that. And that's why we will mainly talk about metals, because these are used in industry mainly. That's why. Okay. So if you are starting with 1.1 temperature, right? Let us say you are talking about T or 0 degree centigrade, let us say. And at this point, if you are saying the resistances are not. Okay, and you increase the temperature, you are going for heating. Okay, you are heating. So what will happen? It will reach some temperature. And at that point, let us say resistance is RT. Okay, then we can have one formula, and you all of you are aware of that formula. I'm writing the same now. Right? So whatever change in the resistance that we are having, change in resistance we are saying RT minus R0 will be the change in the resistance, right? Of course, pehle R0 tha 0 degree pe, at T degree centigrade it became RT, so change in the resistance is RT minus R0. Point number 1 is directly proportional to R0, initial temperature that you have. Okay? Second thing, it is directly proportional to temperature difference. New temperature, we can say, that means T degree centigrade. And third thing, it depends upon the material. On nature of material. Okay, so what we can write using that? Very well, we can write, yes, RT minus R0 is going to be proportional to initial temperature and change in the temperature that you had. If we'll put proportionality sign nikal ke equal to sign RT minus R0 is equal to alpha R0 T. If I shift this R0 on this side, we are going to have RT is equal to R0 मैंने common लिया 1 plus alpha T. Yeah, so this is the formula where you call alpha as the temperature coefficient of resistance. So let me write this thing also. Can I write it? Yeah, okay. Alpha is temperature coefficient of resistance. And we say that yes, alpha is a constant, but keep in your mind, alpha is not constant. For different temperature, there is slight change in the value of alpha. And that's why, agar 0 degree hai, it's best that you will write alpha 0. Right? Because this is our reference, we'll say this is alpha 0. Alpha 0. And this alpha 0 is the. So if you change the temperature, your alpha is also going to change. बाकी का चीज हम नेक्स्ट लेक्चर में लेते हैं, नहीं तो अटेंडेंस के वक्त बहुत प्रॉब्लम होती है. तो पहले मुझे बोला, हैव यू अंडरस्टूड दिस थिंग? यस एवरीवन?
Yes, ma'am.
Yes, ma'am.
गुड. किसी को कुछ डाउट है?
No, ma'am.
नो.
So what is that PTC and NTC?
अच्छा, I'll write. PTC is positive temperature coefficient. Why positive? Because temperature बढ़ रहा है, resistance is also increasing. Negative temperature coefficient. Is it okay? Yeah?
Yes, ma'am.
Yeah. चलो तो let's save this. Can I clear the board?
Yes, ma'am.
Okay.
No, ma'am. No, ma'am. Wait.
Okay, I'll wait.
यार मैंने अभी तो बोल दिया था ना, एक बार क्यों नहीं था? हैं?
Done?
Yes, ma'am. Done.
Okay. Sure. So now we'll go for attendance. Division 2 and Abhishek Belgaonkar. Abhishek, you are there?
Yes, ma'am. I'm there.
Okay. Then Ronak. 43 Ronak. फटाफट attendance दो. Bharat.
Ma'am, he is present. He is with me, Rona.
Okay, fine. Bharat, you are there?
Yes, ma'am.
Okay. Then Bhuvan.
Yes, ma'am.
Yeah. I think Krishna, Chaitanya.
Yes, ma'am.
What?
Yes, ma'am.
Yeah. Daksh, 48.
Present, ma'am.
Yeah. Darshan, 49.
Present, ma'am.
Dev Bharadwaj. Yeah. Okay. Dev, 53 Dev.
Yes, ma'am, present. And ma'am, Devansh Tandon is also with me.
Devansh Tandon. Okay. Devansh Gaur.
Yes, ma'am. Present.
Yeah. Devansh Tandon is with him. Devish.
Present, ma'am.
Yeah. Dev. क्या बोलेंगे? 56 Dev John. है क्या? 56 roll number या there? गायब.
He has gone to the washroom.
Okay, fine. Then Dhruvo Jyoti Roy, 59. Dhruvo, okay. Then Dhruv.
Present, ma'am.
Yeah. Dhruv, 88.
Present, ma'am.
Yeah. Dishant.
Present, ma'am.
अनिमेश है. Gaurav 66.
Present, ma'am.
Okay. Harsh.
Present, ma'am.
Yeah. Harsh Yadav is there. Then 73. Manthan.
Yes, ma'am. Present.
Yeah, Himanshu is there. Hunar.
Yes, ma'am.
Hunarpreet. Yeah. Then Indrajit, ये भी है.
Ma'am.
Yeah. Then Indrayan. 77. Roll number 77. है क्या?
Ma'am, he and Prathamesh is sleeping.
They are sleeping, ना? Prathamesh is
Oh,
sleeping.
भूख
Just
लगी.
give me answer.
What the fuck?
Prathamesh, you are there?
Yes, ma'am.
Don't sleep. Indrayan, you are there?
Ma'am, he is present. Is there?
He is there. Okay. Jaffe?
Yes, ma'am. He is there.
Well, where he is? He was there.
He is gone to the washroom.
अरे everyone had gone for the washroom. ऐसे कैसे चलेगा? When attendance is there, you should be over here. This I'll not allow next time. Sahil?
Present, ma'am.
Yeah. Then Sanket? Sanket, you are there. 82 roll number. Jagtap?
Yes, ma'am. He's with me.
Jatin, 84.
Present, ma'am.
Sleeping, ma'am.
Okay. Jitesh?
Present, ma'am.
Yeah. And Kadam?
I'm Jaffe,
Prasad?
present, ma'am.
Present,
Okay,
ma'am.
fine, Jaffe, I understood. Okay.
Okay, ma'am.
Yeah, okay. So no one is absent in your class. ठीक. चलो. So I'll see the attendance. All the best. All the best.
Thank you, ma'am.
All the best. I'll stop sharing and I'll end the meeting.